Hey y'all, welcome back. Tonight we are reviewing for our Unit 3 test, which covers measurement. Most of the problems that we'll be working will require you to convert units, but we will also be looking at some questions where you will try to find an equivalent rate. So we're going to be working with different units throughout this entire review. The good news is you do not have to memorize any of the conversions that are on this conversion chart. This is going to be given to you on the test, so you don't need to worry about that. However, you can expect there to be several problems where you are not given a direct conversion. And so what I mean by that is, you might get a question that asks you to convert, let's just say, centigrams to, let's say, decagrams, where you don't have a direct conversion for that. It doesn't say like 1 centigram is however many decagrams or vice versa. But with the conversions that are given, you should be able to still get there. It just might take multiple conversions. So for instance, we can go from centigrams to grams, and then from grams to decagrams, but maybe not just directly. So you have a copy of all of these. I gave this to you with your review, so I'm not going to keep scrolling back here. I have this same sheet next to me to kind of help me as we work through these problems, because I don't have all of these conversions memorized, to be quite honest with you. But yeah, let's just go ahead and start working some of these problems, and I think you'll see that for the most part, these shouldn't be too bad as long as you're setting them up correctly. So the important thing here is to identify what you're given and what you're trying to convert it to. So for number 1, it says, Robin bought 6 pints of chocolate milk. How many fluid ounces did Robin buy? So what we're trying to do is go from pints to fluid ounces. And for each one of these problems, I'm going to write out what we start with and what we are trying to end up with, and then show you how we get there. So 6 pints is equal to how many fluid ounces? And we don't have a direct conversion from pints to fluid ounces, unfortunately, so we can't just do a quick conversion. We are going to have to do multiple conversions here. So the first conversion, well, let me just start with all of these, you're going to start with whatever is given, in this case 6 pints, and put it over 1. Then you're going to multiply by each conversion factor that you have, and then hopefully end up with what you need. So we can't go directly from pints to fluid ounces here, though, but we do have a conversion between pints and cups and fluid ounces. So we're going to have to go pints, maybe I'll write that out here, pints to cups, and then to fluid ounces. So we know from our conversion chart that there are 2 cups and 1 pint. Now, as far as setting up this next fraction, you want to make sure that the pints cancel out. So I almost start with the units first, and then fill in the number afterwards. So pints to cups, I have this conversion. You can find that under the capacity section of your conversion chart. And there are 2 cups to 1 pint. So 2 cups to 1 pint. And when you set it up like this with the pints on the bottom, you can see when we multiply these, the pints are going to cancel out, leaving us with cups. So if we were trying to go to cups, all you'd have to do is 6 over 1 times 2 over 1, get 12. But we need to go to fluid ounces. So now we're going to convert cups to fluid ounces. This is a conversion that is given. 1 cup is equivalent to 8 fluid ounces. And so we get the cups to cancel out. And now we'll be left with fluid ounces, which is what we're trying to get. You can actually just type this whole thing into the calculator. All of them are over 1, so you could just do 6 times 2 times 8, although it's not always going to be like that. Sometimes you'll have some numbers in the denominators, so it might just be good practice to just type the whole fraction in, just so that you're used to doing that. So 6 over 1 times 2 over 1 times 8 over 1, and you'll get 96 fluid ounces. So that's the basic structure on how you'll work all these conversion problems. And I'll try to work all these out the same way so that you can kind of start to get a feel for the flow on how these problems should go. Number 2 says a team of researchers spent 4 weeks surveying a plot of land. How many minutes did they spend surveying the land? So we're trying to go from 4 weeks to minutes. Okay, 4 weeks equals how many minutes? We don't have a conversion from weeks to minutes here. What we do have is a conversion from weeks to days, days to hours, hours to minutes. We'll keep that going down here. And and that's it. So just hours to minutes. I'll just leave it there. For some reason, I was thinking seconds. So weeks to days to hours to minutes. So let's start with 4 weeks. So 4 weeks. I always start with over 1. Okay, so now let's go weeks to days. This is a conversion you probably know, but if you don't, that's okay. So 1 week is equivalent to 7 days. Notice I'm putting the week in the bottom. You always are going to put the unit that you're converting from on the bottom and the one you're going to on top, typically. So we want those weeks to cancel out. Now we'll go from days to hours. 1 day is equivalent to 24 hours. And again, we get those days to cancel. And then we need to go hours to minutes. So as hopefully you're aware, there are 60 minutes and 1 hour. And we get those hours to cancel out. So now we're just left with minutes, which is what we want. We have 4 times 7 times 24 times 60. All of those are over 1. So we really don't need the fractions, but it couldn't hurt. And this will equal, it should be a pretty big number, I guess. 4 weeks, how many minutes? That's a lot of minutes, 40,320 minutes. Number 3, it says a half marathon is about 13 miles long. Approximately how many feet is a half marathon? Okay, so what we need to do is convert. So it says a half marathon is 13 mile long. We got, so 1 half marathon, and we need to go from half marathon, that's what we're going to start with, to feet. So 1, I'll just say HM. There's not really a conventional abbreviation for that, but I don't really feel like writing the whole thing out, is equal to how many feet? Now, half marathon is 13 miles long, so we can't go directly from half marathon to feet, but we can go from half marathon to miles to feet. So that's what we're going to do. We're going to go from half marathon to miles, and then miles to feet. So the half marathon to 13 miles, that's not given on your conversion chart, but it is spelled out in the problem. So sometimes that will happen if you're given a unit that's not on your conversion chart, it will be given to you. So just, again, don't worry about memorizing any conversions. So we're going to start with the 1 half marathon, and we're going to convert that to miles. So 1 half marathon is the same as 13 miles. That's given in the problem. And then 1 mile is equivalent to 5,280 feet, which is given on your conversion chart. So just multiplying all this together, we get 68,640 feet. Number 4 says Sawyer is painting his bedroom walls, and the paint costs $36 per gallon. How much does the paint cost per quart? Okay, so we're going from gallons to quarts. So yes, so this is going to actually be a little bit of a multi-step problem because this is a rate problem. So let's start with converting gallons to quarts. Okay, so we're going from 1 gallon to 1 quart here. And I believe I'm just checking over here. Yeah, so we actually have a conversion here. So yeah, we're just going straight from gallons to quarts here. So 1 gallon let's see, is equivalent to 4 quarts. So 1 times 4 is 4. So that's 4 quarts. So the reason why I'm doing this quick conversion here, and this conversion is actually given to you, so you don't really even need to do all that. is so that we can answer this question, because what we're trying to do is find an equivalent rate. Okay, so we have $36, and I'll just put the dollar sign up here, for 1 gallon, which again we just converted was 4 quarts. I'm actually going to change that to 4 quarts, is equal to how many dollars, that's what we're trying to find, in 1 quart. So now we can cross multiply and divide. 36 times 1 equals x times 4. So 4x equals 36. Divide both sides by 4, and you get x equals 9. So the paint costs $9 per quart. Number 5, how many minutes are in 4 hours? Okay, so how many minutes are in 4 hours? So we start with 4 hours, and we want to know how many minutes is that. We're going from, well, this one's pretty straightforward, isn't it? Hours to minutes. We don't need to use any other conversions here. So we'll start with 4 hours over 1. And according to our conversion chart, actually, this is one you should just probably know, even though you don't necessarily have to know for the test. 1 hour is the same thing as 60 minutes. So we just basically have 4 times 60 here, which is 240. Number 6 says how many gallons are equal 12 quarts. So we're saying 12 quarts is equal to how many gallons? Okay, and we do have a conversion here to go straight from quarts to gallons. And so that's given 1 gallon's 4 quarts. So if we're trying to convert 12 quarts, and we know that there are 4 quarts in 1 gallon, now we can see this might be the first time we didn't just get straight ones in the denominator. This is why, just if you want to keep everything kind of standardized as far as how you're computing this, just type in the whole fraction. And that way, if you're used to it, shouldn't really be that big of a deal to solve something like this. 12 over 1 times 1 over 4. In other words, 12 divided by 4 is 3 gallons. Number 7, how many ounces are in 2 tons? Now here we do not have a direct conversion from tons to ounces. Now we do have one from pounds to ounces. There are 16 ounces in a pound. And we have a conversion from tons to pounds. There's 2,000 pounds in a ton. So we're going to have to do multiple conversions here. So we're trying to go from 2 tons to how many ounces? That's really the question here. To get there, we're going to start with tons, and we're going to go from tons to pounds. LBS means pounds. Not really, I guess I could probably look up why, but I'm not really sure off the top of my head why pounds is LBS. I'm sure there's a good reason, probably different language or something. And then we're going to go from pounds to ounces. Okay, so we'll start with 2 tons over 1. Multiply that by our conversion factor from tons to pounds. So 1 ton is equal to 2,000 pounds. And then convert pounds to ounces. 1 pound is equal to 16 ounces. So to convert 2 tons to ounces, we're going to do 2 times 2,000 times 16, all those over 1. So you could just multiply the numerators out, and we get 64,000 ounces. A lot of ounces. Okay, number 8. Lincoln pours 2.5 liters of soda and 1.5 liters of juice into a large pitcher. Looks like we're missing a word there. Into a large pitcher, not just liters of juice, a large pitcher. Anyway, how many kiloliters are in the pitcher? So first, let's figure out how many liters total. It doesn't really need, it's not asking you to distinguish between liters of soda and liters of juice. So let's just add that together. So 2.5 plus 1.5 is going to be 4 total liters. So what we're trying to do is convert liters, say 4 liters, is equal to how many kiloliters? And I believe we can go straight from liters to kiloliters. On our conversion chart, it says that there are 1,000 liters in 1 kiloliter. So we'll start with 4 liters, and there are 1,000 liters in 1 kiloliter. So 4 over 1 times 1 over 1,000, which would be the same as like 4 over 1,000, is 0.004 kiloliters. Number 9, Luna finds that the distance between two cities is 38 million milliliters. What is the distance between the two cities in kilometers? So we're going to go where the question that's being asked here is what's 38,700,000 millimeters? What is equivalent to that in kilometers? So how many kilometers is that? As far as what our units are going to be, I think you can't make your way from millimeters to kilometers, but honestly, I think it's like easier conceptually, if we're going to like try to work it the same way, is to actually go from millimeters to meters and then meters to kilometers. That way you can use the conversions that are on your conversion chart without having to figure out how many millimeters are in a kilometer. So we'll start with the 38,700,000 over 1. Our first conversion factor is going to take us to meters. There is 1,000. Oh, I forgot my units here. Millimeters. There is 1,000 millimeters in 1 meter. And now let's go meters to, what was it? Kilometers or kilometers. So there are 1,000 meters in 1 kilometer. And now we could just go ahead and multiply these out. We got 38,700,000 over 1 times 1/1000th times another 1/1000th. And that gives us 38.7 kilometers. Number 4 says 4.5 kilograms is equivalent to how many hectograms? Okay, once again, you could go from kilograms to hectograms. If you really understand those metric units, you can really just multiply by 10 here. But I think for most of us, it's going to be easier to go through these conversion factors and just go through 2 of them. So the question's asking 4.5 kilograms is equal to how many hectograms? And so we're going to go from kilograms to grams to hectograms. So 4.5 kilograms over 1. We're going to multiply by our conversion factor here. There is 1,000 grams in a single kilogram. So now we're all the way down to grams, but now we're going to convert back up to hectograms. There's 100 grams in 1 hectogram. So 4.5 times 1,000 divided by 100 is 45 hectograms. Number 11, approximately how many deciliters are in 8 cups? Okay, here we're going metric to customary. So just be careful. We're not going to have a direct conversion here. I'm looking at my conversions over here on my conversion chart. Hopefully you have that next to you as well. I think let's go ahead and let's write down what we're trying to do. We're trying to convert 8 cups to deciliters. And it looks like our best bet here, or at least what I'm going to do, there's a couple different ways you can go since we're dealing with a conversion in between the systems. But I think I'm going to go from cups. We have a conversion from cups to milliliters. And then once we have milliliters, we can take that to liters and then take liters to deciliters. So I think this is our path to victory here. We're going to start with 8 cups. And we're going to convert that to milliliters. Now on our conversion chart, we see that 1 cup is equivalent to 237 milliliters. This is a given conversion. And now we can go milliliters to liters. There are 1,000 milliliters in 1 liter. And then we're going to go liters to deciliters. So 1 liter is equivalent to 10 deciliters. So now I got to pull out the calculator. We're going to multiply all this out. 8 times 237 times 1 over 1,000 times 10 gives us 18.96 deciliters. Number 12. Cooper is writing a report about the height of different structures. He notes that one structure has a height of 13 meters, but he needs to convert the height from meters to yards for his report. How many yards is the height of the structure? So 13 meters is equal to how many yards? Should be pretty close. Not exactly, but a yard is roughly a meter. It's not exactly the same. A yard is 3 feet, where a meter is a little bit more than 3 feet. So it's not exactly the same, but they're similar. But anyway, we're going to start with the meters, and we're going to take meters to feet because we have that conversion, and then we can go feet to yards because we do not have a direct line from meters to yards here. But we can go meters to feet. So I'm going to start with 13 meters and convert that to feet. Now this is an irrational conversion, so we're just going to have to use the decimal approximation that's given, which is that 1 meter is the same as 3.28 feet. And then we're going to convert feet to yards. Now they're exactly 3 feet in 1 yard. And so now we're ready to multiply all this together. And I get 14.21 yards. So pretty close to the same number, 13, 14. The yards, are only 3 feet, whereas a meter is 3.28 feet. So a meter is a little bit longer than a yard. So it makes sense that you'd have a little bit more yardage than meters. Number 13, find the number of liters in 15 quarts. All right, well, here we go. We're going 15 quarts is equal to how many liters? And I think we could just go straight from quarts to liters. Let me just kind of look, make sure we have that conversion. Yes, 1 liter is 1.06 quarts. So yeah, we can go directly from quarts to liters. This is only going to take one multiplication here. So we start with 15 quarts. And we're going to multiply by the conversion here. We need quarts on the bottom, so let me start with that. Liters on top. And 1 quart is equal to 0.95 liters. So 15 times 0.95 is 14.25 liters. And just as a reminder, I am using a calculator here. I've just got a calculator out to the side. I've got my conversion chart out to the side. Apologize, I need to find a way to kind of show all these 3 things at the same time, but hopefully you've got your calculator, you've got your conversion chart next to you, so you can follow along here. Number 14, Delaney walked at a rate of 92 feet per minute. What was her approximate speed in miles per hour? Okay, so there's really 2 things happening here. We need to convert feet and minutes to miles and hours. So we're changing the units. So yeah, I guess let's do that. Now I'm going to work this a little differently, but hopefully you can kind of see. So 92 feet per 1 minute, and we're going to start with going from feet to miles. So there are 5,280 feet in 1 mile. So this is going to give me miles per minute. That doesn't quite get me to miles per hour, but I'm going to start there. Okay. Now I do want this one down here. I've got miles per minute, but whatever this multiplies out to be will give me miles per minute. But what I really want is miles per hour. So I'm going to multiply by one more fraction here to get rid of those minutes and replace it with hours. I'm going to actually put the minutes on top, the hours on the bottom. When you're dealing with these rates, the unit that comes after the word per, like per hour or per minute, that is going to be in the denominator. Okay, so we're going to convert here. We know there's 60 minutes in 1 hour. Now we can get our minutes units to cancel. And look, we're left with miles per hour, which is what we want. So now we'll go ahead and multiply all this out, and we'll get our final answer, which is about 1.045 miles per hour. Number 15 says the cruising speed of a 747 airplane is approximately 9,944 inches per second. What's the speed in feet per second? Okay, so we're going to start with 9,944, and that's inches in 1 second. And what we're trying to convert it to is feet per second. So the per second is fine. We don't need to mess with that. We just need the feet. So we need to convert inches to feet. There are 12 inches in 1 foot. So we get those inches to cancel out, and now we can just multiply 9,944 over 1 times 1/12. Or you could think about it as just 9,944 divided by 12. Either way, you're going to get 829 feet per second. Right? Notice the units that did not cancel: feet and seconds. Number 16 says an Olympian swam a 200-meter freestyle at the speed of 1.7 meters per second. An Olympic runner ran the 200-meter dash in 20.3 seconds. Approximately how much faster was the runner's speed than the swimmer's speed? So they're already telling us that the runner is going to be faster, but the question is by how much? So let's find the speeds of both, and then we can find the difference. Now, the swimmer is given in meters per second. So let's just use that as our baseline here. So the swimmer is 1.7 meters per second. And so now let's calculate the runner. We need to do it says the Olympic runner ran the 200-meter dash in 20.3 seconds. So there's 200 meters, 20.3 seconds. So we need to convert that to 1 meter per 1 second. And so like we talked about in class, the way to calculate your speed is just distance divided by time. So if the runner went 200 meters in 20.3 seconds, if we divide 200 divided by 20.3, I get 9.85 meters per second. So clearly the runner is really much faster. So the difference between their speeds is going to be 9.85 minus 1.7, and that is 8.15 meters per second. So this is the difference in their speeds. So that is really what we're looking for here. It didn't ask what was the runner's speed. It says how much faster was the runner. So let's say answer this as a complete sentence. The runner was 8.15 meter per second faster than the swimmer. Okay, number 17, it says the table shows the distances and times that 4 people ran. Who ran the fastest? Oh gosh, we're going to have to basically compute all of the rates here. So Anton, Betsy, Christine, Donovan, A, B, C, D. Let's find what their actual rates are. And we're looking for who ran the fastest. So for Anton, we've got 3.2 miles in 20 minutes, which is 0.16. So that's miles per minute. And all of these are in miles per minute. So you really aren't going to have to worry about the units too much in this problem. We're just looking for who is the fastest. So Betsy went 3.4 miles in 20 minutes. Looks like they're all 20 minutes, so we can just divide them all by 20. 3.4 divided by 20 is about 0.17 miles per minute. So far Betsy's the fastest because we got 0.16 and 0.17. Christine was 2.6 miles in 20 minutes. Let's just move all this over, give myself a little bit more space to work here. There we go. Okay, so C, Christine, 2.6 miles in 20 minutes is when we divide that 0.13 miles per minute. Okay, so still so far, Betsy seems to be the fastest one. And then let's check this last one. Donovan, 2.8 miles in 20 minutes is going to be, let me just erase this so it's a little easier to read. And that is in, let's see, what would that be? 2.8 divided by 20 is 0.14. That is also in miles per minute. So who's the fastest? It looks like Betsy is the fastest. Okay, so a couple notes here that I think we should write down just for your studying purposes. I'll say to find the speed, remember that speed, or here, maybe I'll write it up here since we started with that. Speed is going to be the distance divided by time. And you can actually rearrange this equation any way that you want, depending on what you're looking for. So, for example, if you're looking for time, time is going to be distance divided by speed, and then distance is the speed times the time. So you can rearrange that equation however you need it to go, but really for this test, you're just going to want it equal to speed. Okay, let's put our final answer here. Betsy was the fastest. Way to go, Betsy. You win. All right, now starting with number 18, now we're getting into these like TSI style problems. These are the kinds of problems that you'll see on the TSI rather than just, my Unit 3 test. Still going to take like the same ideas that we're working with here. Let's see if we can't just solve some of these problems. And also, these are multiple choice items. So I also want to show you like how you might be able to work these backwards, like using the answer choices to your advantage on some of these problems. 15 says whoever has 5 bushels of cereal, he wants to pour all the cereal into boxes that can each hold 1 peck. You see that unit very often. How many boxes will he need? And it says that 4 pecks equals 1 bushel. So that's going to be our conversion that we need. So Luis is going from bushels to pecks. Can't spell today, pecks. And so 5 bushels equal how many? It says how many boxes, but also says a box is just 1 peck. So it's basically the same unit. So how many pecks? Okay, so we're going to start with that 5 bushels. We're converting to pecks here. The conversion's given. 1 bushel is the same as 4 pecks. So 5 times 4 is 20. So 20 pecks. Each peck is 1 box. So yeah, we got 20. Number 19. Rick traveled 6.8 kilometers of his delivery route in 1.2 hours. At this same rate, which of the following is closest to the time it'll take for him to travel 20 kilometers? So this is going to be a case, and there's going to be a lot more conversion on the test than this, which is finding an equivalent rate. But anytime you're trying to find an equivalent rate, you can set this up using a proportion or a cross products situation. Now, this is going to be used when you do not have to convert the units. If you got to convert the units, you should just do that up front, and a lot of times that's just going to get you to where you want to go. But if you're trying to find an equivalent rate, which is where the units are the same, in other words, in this case, we're saying Rick traveled 6.8 kilometers in 1.2 hours. We want to know how many hours, X hours, did it take him to go 20 kilometers? So notice our units here are the same, kilometers per hour, kilometers and hours. And so anytime you're trying to change what the rate looks like, but not change the units, you're going to set up a proportion to do that. So here, we're going to use the cross products property and multiply 6.8 times x. So 6.8 times x equals 20 times 1.2. And again, I'm just using the cross products property here, something we learned in class. Sometimes it's called cross multiplication or the butterfly method. Kind of take your pick there on which one you want to call it. But yeah, so 20 times 1.2 is going to be 24. So we've got 6.8x equals 24, and then we'll divide both sides by 6.8. So 24 divided by 6.8 gives me roughly about 3.5. It's actually like closer to 3. Looks like it's actually a very long decimal here. But it says which one is the closest to the time. So, and you can't even read what I wrote there. But if you look at the answer choices, the only one that even comes close to making sense is choice B. Number 20 says if the price of 3 oranges is $1.95, what is the price of 14 oranges? So again, this is another equivalent rate problem. So we're going to set up 3 oranges costs $1.95. Okay, so that should be equal to the 14 oranges. As to how many? What's the cost here? Now, I want to show you there is another way to do this one, but let me just show you this one real quick because this is kind of how I showed you how to work these equivalent rate problems. We're going to do 3 times x equals 14 times 1.95. 14 times $1.95 is 27.3. So we get 3x equals 27.3. And if I divide that by 3, I'm going to get 9.1. Okay, so we can see that our answer is C right away. It doesn't take too much work to get there. There is another way how we could do this. And you can kind of choose, and whichever way makes more sense to use, fine with me. But here's our alternate path to victory. If you know that 3 oranges is $1.95, then how much is each orange? Like if we just find the cost for 1 orange, all we really need to do is just divide 195 by 3. 195 by 3 is 65 cents. So if you know 1 orange is 65 cents, and again, I'm getting here just by dividing by 3. Okay, didn't even solve the proportion the same way. So if I divide by 3, I get 65 cents. If I know each orange is 65 cents, then 14 oranges, or 14 times 65 cents, is 9.10. So you can get there either way. It doesn't really matter to me how you get there. Just make sure you get there correctly. Yeah, that's it. Number 21. If a car travels at an average speed of X miles per hour, how far will you travel in 90 minutes? Okay, so we're trying to convert hours to minutes here. So I think, so X miles per hour in 1 hour, and we want to change that to a question about distance, how many miles in 90 minutes. So this will equal, let's convert this to minutes first of all. So we need to get rid of the hours. How are we going to get rid of that hours? That means we need to put hours up here, right? And change that to minutes. Now there are 60 minutes in 1 hour. Okay, so we can do X over 60, and that'll be that is miles per minute. Okay, so those are X miles in 60 minutes. Maybe I'll just join these. How do I want to write this? I guess I'll just write it like that. X miles in 60 minutes. So if you go X miles in 60 minutes, the question is how far do you go in 90 minutes? So not only do we have to do this conversion, but now we've got to set up the proportion. Okay, X miles in 60 minutes is equivalent to how many, and I'm already using X, so I kind of can't use X again. So I'll just use like a question mark here, and that's actually what we're solving for. How many miles in 90 minutes? So here we're going to solve for question mark. The kind of the weird thing about this is X is going to be in our answer. Now, this is kind of a weird problem, I think, but I want to show you a shortcut or a kind of a different way how you can approach it. But let's finish it this way so you can at least see this worked out. So we've got 90 times X equals that question mark times 60 using the cross products property. Can I move this up a little bit, give myself a little bit more room? Let's do that. And then we'll move this thing up. I'll just rewrite that. Okay. So 60 times that question mark, that's what we're looking for, equals X times 90, or 90X. So if I solve for that question mark, I just need to divide both sides by 60. So question mark equals 90X over 60. And you can use your calculator to reduce that 90 over 60 to 3/2. So 3X over 2. So our answer is going to be B here. But I think there's an easier way to do that. And that is going to be to like actually pick a number instead of X and see if it works out. So I think if it, I guess you'd have to work it out the same way. There's not really going to be like a back way to get there. Yeah, I think that's just going to be how you have to solve that one out. Number 22 says the ingredients listed below. Make 40 peanut butter balls. Okay, so this is making 40 of these peanut butter treats. The school party has 120 children, and each child will be given 2 peanut butter balls. How many cups of peanut butter must be used in order to make exactly enough peanut butter balls for the children at the party? Okay, so we're just really focused here on the peanut butter. We don't care about anything else. So this 1.5 cups, I'm actually just going to rewrite that as 1.5 just to make the math a little bit easier. So 1.5 cups of peanut butter. So let's write this down. 1.5 cups of peanut butter is going to give us 40 peanut butter balls. I'll just call them PBBs. And we want to know how many, we want each kid to get 2. There's 120 kids. So first of all, 120 kids, and each get 2 peanut butter balls, PBBs. So that's going to be, we need 240. Right, so we're going to set up a little proportion here. Let me erase this. Basically, I'm going to rewrite that as a proportion. 1.5 cups of peanut butter is to 40 peanut butter balls. And that's equal to, so this is an equivalent rate. How many cups of peanut butter if we need 240 peanut butter balls? Okay, so we're going to use this another cross multiplication here. We're going to do 40 times X and 240 times 1.5. So 40X equals, let's see here, 240 times 1.5 is 360. And then if we divide both sides by 40, should get our answer here. 360 divided by 40, is that 9? Yep, it's 9. Okay, so there's number 22. Number 23, running at an average rate of 9 miles per hour, how many minutes would it take him to run 3 miles? So another equivalent rate problem, 9 miles in 1 hour is equivalent to 3 miles in how many hours? So that's going to be our X. So we'll multiply 9 times x and 3 times 1 to get 9x equals 3. Divide both sides by 9, and we get 1/3. Okay, now we want to be careful here. The question is asking for how many minutes. So we can go one of two ways. We could either say, okay, well, what's 1/3 of an hour? How many minutes is that? Or we could go back to the original problem, which might be easier, and just kind of rework it out. Because we don't want minutes, we don't want hours, we want minutes. So let's change this from 1 hour to 60 minutes. And then just rework the problem the exact same way. But now we'll have the correct number of minutes. So we've got 9 times x equals 3 times 60. 3 times 60 is 180. So divide both sides by 9, and we get x equals the correct answer here, which is 20. So it should take 20 minutes to run 3 miles. Number 24. Rachel made a casserole for dinner. The recipe says to bake the casserole in the oven for 1 hour, 45 minutes. Remove it from the oven, let it cool for 10 minutes. If she puts the casserole in the oven at 420, what time will it be ready to eat? So this problem is really kind of misplaced in the big scheme of things. This is really not a unit conversion or like a measurement problem. This is more of just like a quantitative reasoning problem. I really couldn't find a good unit to put this problem in there because I've seen a similar problem like this on the TSI before, or at least I haven't actually seen it, but I know that they've put one on this like it before. So let's just see if we can't reason our way through it. So we're going to start at, it puts the casserole in at 420. Okay, so 420 we begin. And it's got to cook for 1 hour and 45 minutes. So let's just say we'll do if we add the hour plus 1 hour, that's going to take us to 520. And then an extra 45 minutes. So let's be careful here because we don't have a time like 565. No, after 60, we got to go up an hour. So an extra 45 minutes is going to take us to 6:05. Okay, so this is when we're done cooking. Okay, and then let it rest for 10 minutes. So plus an extra 10 minutes takes us to 6:15. All right, 6:15 is our answer. So kind of an oddball question to throw in here, but I want to make sure at least one time this year you get some experience with a problem like that. When we get a little closer to the actual TSI test, we might do a few more like this, but there's not really like a full unit on that. Okay, where are the rest of the problems, or is that it? Hang on, let me try to refresh this. All right, there we go. So we only have a few more problems here. Number 25 says Aristotle drove from Austin to Blanco at an average speed of 45 miles per hour. If he drove for 40 minutes, how far did he travel? Okay, so just recall that speed is distance over time. Okay, so there's two ways we could approach this. One, if we're just looking for the time, we could just rearrange this as time equals distance over speed, as long as all the units check out. But because of that whole change from miles to or hours to minutes, I don't think we're really going to want to do it this way because I don't want you to get thrown off by that conversion. I think we're going to try to approach this as number one, a unit conversion problem, but then number two, an equivalent rate problem to try to figure out how far did he travel. So we're looking for how many miles, right? So if we did 45 miles per hour, and we know he drove for 40 minutes, so I'm just going to get ahead of the game and say, okay, well, drove 45 miles in 60 minutes because that's what 1 hour is. And we want to know how far did he travel. Okay, so He traveled for 40 minutes, and we want to know how far that is. So we'll use a little cross multiplication here. X times 40 is going to, or sorry, X times 60, 60X, and then 45 times 40 is 1800. Divide both sides by 60. We should get our answer here, which is 30 miles. All right. Oh, I guess that was it. It was just that one last problem. Well, that about wraps it up for tonight's review. Hopefully you feel a little bit better about these types of problems, but if you're still struggling, please come see me in the morning or reach out with an email. I'll try to explain these problems a little bit more in depth for you. But otherwise, y'all have a great day, and I'll see you next time.